All right, this is number 3 in the EPIC SAT walkthrough series. We're on practice test 1, the reading test. And in the reading test, we've already done the first 2 passages. So now we're on to the third one. The third one, I can see right away. Okay, DNA. We're talking about DNA and its composition. Let's see. We have the molecule is a very long chain, the backbone of which consists of an alternation of sugar and phosphate groups, etc. Sequence of bases along the chain is irregular so far as is known. Okay, great. And then we have this part, purines and pyrimidines. Even if you don't feel comfortable with the science, the vocabulary that they're dropping, don't worry about it. You just have to know that they're splitting things into one group and another. And the more they categorize things, the easier it's going to be to figure out what the answer is. All right, this one we have the first feature is that it's not one chain, but 2. So the first thing we can write down here is 2 chains. All I want for my birthday. Yeah, okay. So we have it has been assumed that there was only one chain. However, the density and X-ray evidence suggests strongly that there are 2. So they're basically saying we have a lot of evidence that there are 2 chains in the DNA backbone. The other biologically important feature is the manner in which, so how they are held together. Okay, so this is the second part. So we have there are 2 chains, and this is how they're held together. I'm not even going to bother going into it. Because when I'm asked a question about this, I know that if they ask about the structure and how it's held together, I know this will become important. We believe the bases will be present almost entirely in their most probable form. Okay. The only pairs of bases possible are adenine with thymine, so A and T, and guanine with cytosine, G to C. All right. So that's another good note. It's like this is how they have to be. So this is how they absolutely have to be. Anyway, so the partner on the other chain must always be the same. So the phosphate sugar backbone is completely regular. So they're saying they're wrong that it's irregular. Any sequence of the pairs can fit into the structure. It follows that blah, 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 blah. Right. If the actual order of the bases on one of the pairs of chains were given, one could write down the exact order of the bases on the other one. So they'd be able to okay, so one chain is at work is the complement of the other. So that's how it might duplicate or copy itself. So you can make the copy only if you know the order of the bases. If you don't know the order of the bases, you're out of luck. All right, so we're only 2.5 minutes into actually reading this, and then we've got this graph which gives us a bunch of organisms and all of the different percentages and how that works. We don't need to go into that yet. We'll wait until we get questions about it before we spend any time on it. So again, we're talking about the structure of DNA. It has 2 chains, sorry, and also they're held together in a certain pairing. So the bases are held together A to T, G to C, and that if we know what they are, then we can pretty much figure out how the other one will be, and we can figure out how DNA can copy itself. On to the questions. Why do they use that word backbone? Okay. Now, you may be saying, hey, that's not what it says. But again, remember, we ask a question. When the question doesn't have a question mark, we say, why do the authors use this word backbone? Why are they doing it? Is it because only very long chains of DNA can be taken from an organism with a spinal column? Hey, I don't remember writing anything about an actual vertebrae, it's backbone like we have as mammals. No, that's not what we're talking about. And also this word only probably makes it a wrong answer. The main structure, so already I'm like, yes, I like this answer, of a chain in a DNA molecule is composed of repeating units. Well, we did have that it had alternating. That's not spelled right. We have alternating units, so repeating units. I'm going to go with B and then check out the others. A chain consists entirely of phosphate groups or of sugars. No, that's not it. It's both. It's a phosphate and a sugar. Nitrogenous bases form the main structural unit. No. Okay, it's the repeating units of phosphate and sugar groups. 23. A student claims that nitrogenous bases pair randomly with one another. Randomly? Well, we may have already stumbled across something. It doesn't say it's random, does it? It says they have to be in a certain configuration. So which part contradicts that? So we have 2 answers that are in the very beginning, and then we have these 2 that are sort of in the middle. just finish writing that. I spelled it right, at least. Okay, so in the very, very beginning, are we asked about the nitrogenous bases? Okay, so attached is a nitrogenous base, but it's not talking about whether it's random. Okay, it does say here, so far as is known, the sequence is irregular / random. But then we're trying to counteract that. So we don't need this part. So those two answers are definitely wrong. It has to be somewhere in the middle. We know that A and B are wrong because in the beginning, it's not contradicting that random thing. It's actually affirming it. So where does it say it's not random, but it's very much shown? We have only certain pairs. One member of a pair must be a purine and the other a pyrimidine. Okay? So there you go, somewhere in that area. So lines 27 through 29 is where they say, absolutely, there must be a certain structure to this. Okay, so D for number 23 makes the most sense. Okay, on to 24. The second paragraph, what do the authors claim to be a feature? Okay, well, we notice that this is the paragraph they're talking about in here. The first feature is that it's two chains. So we need an answer that has two chains. DNA consisting of two chains. There's our answer. Simple, simple, simple. When they tell you which paragraph to look for, the answer, oh man, these short answers are really nice, so you got to fly through them. All right, number 25. We're moving along well. The author's main purpose. Main purpose. So why do they use the X-ray and density argument? Why do they talk about those two things? Sorry for shaking the screen there. Okay, establish that the molecule, DNA is the molecule that carries genetic information. Well, no, we already know that that's sort of true. If you know anything about science, you're like, yeah, I got that information. That's not what I'm asked about. I'm asked, why did they talk about X-ray evidence? Okay, present an alternate hypothesis about the composition of a nucleotide, not about a nucleotide. They only barely mentioned that. Provide support for the author's claims. Right away, I like that answer. Anytime an answer says something like provide support for author's claim, like, oh, that's a nice general. When you read an article or a journal or an essay, that's what details do. They support the author's claim. That's what it's supposed to do about the number of chains. So is the part about X-ray evidence and density in the paragraph where they talk about two chains? X-ray and density is in this paragraph with the two chains. Bingo. That's our answer. C, providing support for the fact that there are two chains in the molecule. Number 26 now. The author's statement, if a pair consisted of two purines, there would not be room, implies what about the pair? So what do we know about a pair of these molecules? A pair of purines would be larger than the space between a sugar and phosphate group. That doesn't make sense. The pair of purines would be larger than a pair consisting of a purine and a pyrimidine. Yeah, that's a better comparison. You can't compare a pair of purines to the space between a sugar and phosphate group. That doesn't make sense. That word space does not match with pair, but pair matches with pair. Pair here, and this one also has that. So we do have to look at it. So is it saying that a pair of purines would be larger than a pair consisting of one and the other? Well, I kind of remember them saying exactly that. They say if a pair consists of two purines, for example, there would not be room. So two purines would be too big. So B is the right answer after all. 27. The author's use of the word exact, specific, and complement function. So again, why are they using those words? Why do they use these particular words in that final paragraph? All right, well, let's go back to it. You say, if the actual order of the bases on one of the pair of chains were given, one could write down the exact order because of the specific pairing. So because we know that much about it, if we were to know one of the pairs or the order of the pairs, then we'd be able to figure the rest out. Okay, so confirm that nucleotide sequences are known. Well, it says if we knew, so no, that's not right. Counter the claim that the sequence can occur in any order. Okay, all right, well, a little bit. I'm kind of meh on that answer. Support the claim that the phosphate sugar backbone is completely regular. Oh, what do you think about that? I'm not sold on that one. I'm going to say no. It doesn't support. There's no claim support of that regularity. So I'm going to say no to that. Emphasize how one chain may serve as a template to be copied. Okay, I remember this. This has got. I wrote down the word copy right here, because that's how we can duplicate. So a template, a copy. D is the answer. Boy, that was a lot easier than I made it because I went A through D. But it's important. I mean, it didn't take that much time to go through that whole thing bit by bit. Okay, but D was clearly right. Now, we have table and passage. So we're combining the table and the passage. Which choice gives the correct percentages of the purines in yeast DNA? So we're looking for the purines in yeast DNA. Oops, excuse me. Made a little errant mark there. Okay, the purines in yeast. So we're looking here. So which of these four represent the purines? Well, it says here, okay, the purines are adenine and guanine. So we're looking for these two. Okay, so in yeast, it's 31.3 and 18.7. 31.3, 18.7. There's 31.3, there's 30. So A and B are out because they don't have either of those. 18.7, 31.3, C is the answer. That was easier than I made it too. See, you can take your time. You're going to get the answer if you take your time. You can rush through it and get some of these answers, but I guarantee you've still got time. We're not even done with this whole entire thing. Do we have any more questions? This is it. We got 3 more questions, and we haven't even, I've been talking way too much. Imagine if I wasn't here. Imagine you could shut me up and just do the test. How much time you'd have. Okay, do the data in the table support the author's proposed pairing? So we have to know right away, what is that author's proposed pairing? Okay, that was down here. Okay, we believe, this is what the authors are saying. We believe that the bases, only pairs of bases possible. This is the author's proposed pairings. I remember this. Adenine to thymine and guanine to cytosine. So A, T, G, C. All right, so does the data support this pairing right here? So if I look at adenine and thymine, will the numbers be pretty much the same? 26.8, 27.2, close enough. 33, 31, 28, 24, 28, oh, I'm sorry, 28.0, 28.4, 28.6, 28.4. Yep, so far so good. So these two go together and these two go together. That has to be a yes. So we can get rid of the no, because it's definitely true. So here it says yes, because for each given organism, the percentage of adenine is closest to thymine. Yep, there's our answer. That's exactly what we discovered. Number 30, according to the table again, which of the following pairs of base percentages in sea urchin provides evidence in support of that? So we need evidence that supports, okay, that adenine goes to thymine and guanine goes to cytosine. Again, we just need to prove that this is true using sea urchin. Okay, so sea urchin, 32.8 and 32.1, that's a difference of only 0.7. 17.7 to 17.3, that's a difference of 0.4. So these two numbers are going to be used as evidence. 17.3, 17.7, bingo. All the others, these are way off. These are not A to T. This is the only one that's A to T, or G to C. Okay, so based on the table again, the percentage is the percentage of adenine in each organism's DNA the same, or does it vary? And which statement made by the authors is most consistent with that? So we need the same, or it varies, it varies. Okay, so again, pay attention to how these questions are being asked. Are they the same? Well, I think that we could say that they all vary a little bit. They're never ever the same from organism to organism, right? And, or I could say, yeah, it definitely varies, so it can't be the same. And then we have to look for either lines 36 to 38 or 41 to 45 to say that it varies. Okay, so the first one, excuse me. Hold up. So at 1426, I kind of went freaky. Okay. Okay, so we're looking at lines 36 through 38 or 41 through 45. So 36 through 38 say adenine can occur on either chain, but when it does, no, that doesn't say anything. So I know it's D because C doesn't have anything to do with it. The answer has to be D, and we're done with this. So again, imagine if you didn't have to listen to me explain anything. how quickly we're able to move through these. All right, I'll see you for the fourth part of the series in just a couple minutes. Have a good one.